Hello everyone. Consider two planes and both are charged, okay? And one plane is infinite in size and other one is finite in size. But both are large. The plane which is finite in size, that is also very large. And other one is infinite and both are charged. So question is, if you talk about the field strength, electric field strength of both the planes, then why they differ? Why they differ? That is the question. And that is the topic of discussion in today's video. Okay, so what is the mystery? So first let's talk about infinite plane. So when the plane is infinite in size, means in all directions. Along the plane in all directions, there is no limit. It goes up to infinity. Means the plane stretches up to infinity in all the directions across the plane surface. Now, if you consider any point on that surface, so that point is equally influenced by all the directions. Means the contribution of surrounding points on that specific point, which point you are considering here for the calculation of electric field strength. Okay, so you can easily see that since the size of the plane is infinite, therefore any point on the plane is influenced equally from all directions. That means from the plane, equal contribution or equal influence is there. That means on any point on the infinite plane, the field strength is constant. It does not change. Okay, logically you can easily say this. Logically, since reason is what? Reason is since the size of the plane is infinite. This is the only reason. Okay, and mathematically actually Gauss's law is used to calculate electric field strength, that is known to you. And if you use here Gauss's law to calculate the same, then you will get E is equal to, E means capital E is used here. E means here electric field strength, which is equal to sigma by 2 epsilon 0, where sigma is the surface charge density. That means coulomb per square meter. Surface charge density means charge per unit area of the plane. That is known as surface charge density, denoted by sigma. And epsilon 0, that is known to you, that is the permittivity of free space or vacuum. Okay. So this E is constant. You can see easily that in this expression for electric field strength, there is no distance. Distance, that term is absent here. That means it is independent of distance. So whatever be the position of the point on the infinite plane, the electric field strength remains constant. Here also same procedure is followed. Take any point on the surface, I am talking about right now infinite plane. Take any point and surround that point by a Gaussian surface or Gaussian pillbox. And you proceed to calculate, then you will get that E is equal to sigma by 2 epsilon 0. You can see the equation on the screen. Okay, now you would consider the finite plane. So whenever you are considering the finite plane, and I have already mentioned in the very beginning of this lecture that the finite plane, this is also very large in size. So since it is very large in size, so therefore central region of the plane, central region of the finite plane is equally influenced from all the directions. So in the central region that doesn't mean a point. Central region means a specific area. Okay. So on that specific area, electric field strength remains constant. But as you move toward the edges of the finite plane, in that case the field strength decreases. With increasing distance from the central region, if you measure the distance from the central region, then with increasing distance the electric field strength decreases. And this is known as edge effects. because as you are moving toward the edges, field strength decreases. So in that case, what happens, electric field lines, electric field lines, so they spread out. Okay, electric field lines spread out as you move toward the edges of the finite plane. So in the central region it remains constant, means the electric field strength remains constant, but near the edges it does not remain constant, it does not remain uniform. As distance increases from the central region, the electric field strength decreases accordingly. Here also same procedure can be applied to calculate the electric field strength, that is Gauss's law. Okay, and physicists love very much this infinite plane concept because the mathematical expression is so easy, means the expression is so easy to use for the purpose of calculation. In real world problems, in real world cases, all the planes, whatever be the size, they are finite. Still, this theory can be applied. This theory means what? The theory for infinite plane that is applied for the central region, such as parallel plate capacitors. Okay, they are large enough. Normally, the parallel plate capacitors, the size of the plates are large enough. So the central region can be considered as the infinite plane. Means you can apply there equal field strength at each and every point of the central region, not near the edges. Near the edges, edge effects are there. Okay, edge effects are there, no doubt. Anyway, so this was all about this topic. So difference is what? So in case of infinite plane, field strength remains uniform. It is constant. But in case of finite plane, it is not constant. If you consider the total area of the finite plane, then it is not constant. In case of infinite plane, the field strength does not depend upon distance from the plane, from any point. It does not depend upon distance, but in case of finite plane, it depends upon distance. And in case of infinite plane, edge effects are not there. But in case of finite plane, in case of infinite plane, edge effects are not there, but in case of finite plane, edge effects are there. So these are the differences between infinite and finite plane. And this is known as the infinite and finite plane mystery. Means here I have given the title this way. Okay, I have framed the title this way here for this video. This is not a general term used in physics. Okay. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.